Hi everyone, in today's video we're going to be talking about dimensional analysis, or what I call dim-ana, and it's kind of one of those topics that blows everyone's minds when they first see it, but if you follow the steps that I've given you, then more than likely you're going to have about a 90% success rate. The first step that I tell you in any chemistry problem is, well, really to identify what you're given. And in our first worksheet that we have on dimensional analysis, they make that easy for us. They really just tell us, hey, this is what we're given. So here's step one. Here's an example, 2.45 feet. Step two is to identify, well, what do you have to solve for? And they've also given that to us technically in the worksheet, making it easy. So step two, we have to convert technically feet to miles. And step three is, well, how do you get there? And this is really the most important step because you have to ensure that you set up your units first. So I'm going to go ahead and start with what I was given, 2.45 feet. And that's the only number I'm going to write down for now. From here on out, I'm just going to write my units. I have to identify in my conversion factors, or my list of conversion factors, if I can directly go from feet to miles. In this case, I can. In some cases, I can't, which I would have to have multiple conversion factors if that was the case, converting from one unit to the next until I got to my unit that they want. However, in this one, I can go from feet to miles. Since feet is a numerator as a unit, I can actually put it as the denominator. And that will help to cancel it out. And now also I can change from feet to miles would go as the numerator. So I go back and check, do my units cancel out properly before I put any numbers in? Again, that's one of the most important steps. So feet do cancel out, and I'm left with miles, which is what I want to be left with. Now I look at my conversion factors, or I access the memory in my brain and see that technically in 1 mile there are 5,280 feet. I know my unit is going to be in miles, and that's part of a proper chemistry answer. And I can go ahead and calculate this. By saying 2.45 times 1 divided by 5,280. It gives me this big long string of numbers, which actually happens to be 4.64015, and 15 is repeating forever, it seems. 15, it's repeating for a while, but it doesn't continually repeat. 15, e to the negative 4. So I have to actually truncate that into proper sig figs. The way to do that is I access what was given to me and how many sig figs that was in. From our sig fig rules, you know that there are 3 sig figs here. So my answer has to be rounded to 3 sig figs. It's going to be, I'm going to go to my 4th sig fig right here, which is 0, and ask, does the 0 round my 3rd sig fig up? It does not, so I am 4.64. Careful, you need to have this part right here, which is e to negative 4, so that means times 10 to the negative 4. And again, I include my units, miles. That is how to do a one-step dimensional analysis problem. In my next example, I'm going to do number 5 from the worksheet, and that is 459 feet per second, and they want me to turn that into miles per hour. Now this is ever so slightly more difficult, but not so much. Really what we're doing is we're starting with what we're given. Again, 459 feet, and I'm going to write it like this, per 1 second. Now it does not matter what unit I want to start with canceling out, but I have to choose one, and I cannot cancel out both units at the same time. In this case, just for fun, I'm going to start with seconds. Since seconds is a numerator or a denominator, I'm going to put it as a numerator to cancel it out. And I know I can go from seconds to minutes. And I'm stuck in minutes right now. I'm technically stuck in feet per minute. And I can go minutes into hours. I'm going to go back and double check that I properly canceled those units out correctly. Seconds cancels with seconds, minutes cancels with minutes. I am left in hours, and if I stopped right this second with this dimensional analysis problem, I would be in feet per second. However, they want me in miles, or sorry, feet per hour. They want me in feet or miles per hour. So technically, I can start canceling out my second conversion factor, or my second unit, I should say, by putting that over here as a denominator. I know that I can go directly from feet to miles, just like we did in the last example, and so I cancel out my units, and I'm stuck in miles per hour, which is exactly what I wanted to be stuck in. Only at this time can I put in my numbers. So I know that there are 60 seconds in 1 minute, 60 minutes in 1 hour, and there are 5,280 feet in 1 mile. I'm going to go ahead and calculate that out. 459 times 60 times 60 times 1. And I get an answer. Technically that answer is 1652400. That's my answer A for the top part. I'm going to go ahead and do the bottom. 1 times 1 times 1 times 5280. I get another answer, which is obviously 5280. That's my answer for the denominator. Now, I like to do it this way. There's multiple ways to actually run this math, and they all kind of turn out the same because of the beauty of math. But I'm going to say now 1652400 divided by 5280. And that gives me an answer of 312.9545455. Again, I reference my first given, and that was in 3 sig figs, so I have to round this to 3 sig figs. I go to my fourth, and I say, does my 9 round up my third sig fig, which is a 2? It does. So I have 313, I'm rounded to 313, 3 sig figs, and miles per hour. So that's how you do a not a two-step, but a 2-unit conversion dimensional analysis problem. My last problem that I'm going to do is ever so slightly more tricky, and it's a 2-step problem with square roots. For this one, I'm actually going to refer to our second dimensional analysis worksheet. Let me just reference a problem here that actually is going to work. Number 19. This is dim ana number 2 that I give you. So number 19. It says 8.24 grams per centimeter cubed, or sorry, squared. And they want to turn that into milligrams per millimeter squared. So I go ahead and start with what I was given, 8.24 grams over 1 centimeter squared. Now, for the most part, I like to just ignore the square roots for right now. I put them all in later, and it may make more sense to you. It depends on the way your brain works, but I like to leave them out for right this second. So again, it's just like a normal 2 conversion problem. I can start with either conversion, and I'm going to go ahead and start canceling 1 out at a time. I can go from grams to milligrams in 1 conversion factor, so grams to milligrams. And that's what I need to be left in. My grams cancel out, I'm left in milligrams. If I stop my problem right this second, I'd be in milligrams per centimeter. But they want me in millimeters. So I'm gonna go ahead and place centimeters up here, and I can also go from centimeters to millimeters in 1 conversion factor. So technically, I am left in milligrams per millimeter. It's at this point that I go ahead and pop in my square roots again. The reason why, or my cube roots, doesn't matter, but the reason why is because I realize, hey, this has a square on it. So does that, and well, so does that. As a matter of fact, everything in this conversion factor, because it deals with a squared unit, is also going to be squared. My numbers here are going to be squared. So I know there are 1,000 milligrams in 1 gram, and there are technically 10 millimeters in 1 centimeter. Again, I have to square these numbers. More or less, if you're thinking about how these are distributed, it could be saying the same thing. Your exponent could be like this, right? And then all that distributes to everything in there. So, ultimately, I like to do it like this. I take care of my square roots first. 100 squared, I happen to usually pop this into a calculator, but this one's easy. I know 10 squared is 100, and 1 squared is 1. So because I've done my chemistry in pencil, I go back and actually erase that and put 100 in. And I know that I've already taken care of that square. All right, so well, 1 squared is also 1, so I can erase that as well. Now I can just do my math. Notice how I didn't square any of the numbers in here, and that's because my units weren't squared. So I can say 8.24 times 1,000 times 1 is going to give me an answer of 8240. And 1 times 1 times 100 is going to give me an answer of 100. Well, 8240 divided by 100 is going to give me an answer of 82.4. Again, remember, I squared the numbers inside of my squared units. And you do that for every unit that needs to be squared. Let's just say that I had to go from centimeters to miles, right? My centimeters would go from centimeters to inches, inches to feet, feet to miles. Meanwhile, the feet would be squared, the miles would be squared, the inches would be squared, and all of the numbers attached to those conversion factors would also be squared. Be very well aware of that. So now, my first answer was technically, my first given was in 3 sig figs, and my answer happens to fall perfectly in 3 sig figs. So I don't have to do any rounding here. I just have to include my units, which is milligrams per millimeter squared. I hope this video helped out a little bit. Please rewind, watch as much as you need to. I may have talked a little quickly, but that is how to do different dimensional analysis problems. A 1 conversion factor, a 2 conversion factor, a 1 unit, a 2 unit, and lastly, working with square, cubed roots, or any type of exponents. Hope that helped.